It's a storm. It's a storm. My wig's blown off. I look like Humpty Dumpty. Oh, I wish I knew it was coming. Calvin, didn't you see the weather on the news? Wait, who's on the news? Hi, everyone, and welcome to episode 2 of the Outfox podcast. Outfox is a student-led podcast brought to you by École Campus de Nation. My name is Sauri, and I'm joined by my co-hosts Muhammad, Calvin, Aviva, and Jessica.
Last episode, we discovered creative spaces, from large-scale universities to parking lots, all possible with the aid of geometry, measurements, and a ton of calculations.
Today, the winds have blown us to Meteor Suisse, where we have a store of questions for this episode, such as, what does 20% chance of rain really mean? What tools are used for predictions and data collection?
That's why we have the pros with us to tell us all about the fascinating world of meteorology and its use of mathematics. Joining us today is Aude Untersee.
Hi, Aude. Thanks for hosting us in the Weather Center. We are exploring connection of math in everyday life. So we are excited to speak with a meteorologist. Tell us about yourself and how you got interested in meteorology.
I came into meteorology because I was enthusiastic about outdoor activities. So I sailed a lot when I was young. I was outside doing some hiking, cycling, and discovering gliding when I was a teenager. At the age of 14, I decided to start learning how to fly gliders. Flying glider is strongly dependent on the weather because you need good weather conditions to fly. And then I decided to focus more on weather and meteorology. And then I decided to study atmospheric sciences. So I studied in Paris, also in Toulouse, at the French National School for Meteorology. But I was also from Switzerland, so I wanted to do some weather forecast for Switzerland. And I applied at Meteo Suisse and I got the job in 2020. So I'm working at Meteo Suisse for 6 years.
So for students like us that may be interested in studying meteorology, what is usually the traditional educational path that you take for becoming a meteorologist?
The most common one, a master in atmospheric sciences or in physics. When you enter a National Weather Service, you have an intern training for several months before you get independent on the job and able also to send warnings and to do weather forecasts.
Could you quickly define meteorology?
For me, meteorology would be all the scientific topics related to atmospheric phenomena and explaining what's going on in the atmosphere. So it gathers math, physics, chemistry, and environment sciences in general.
What is the difference between weather and climate?
It's mostly a question of time scale. Weather is a short time scale. It's the evolution of the atmosphere on one day to several days. Climate is on a longer time scale, several years or even several decades to describe what climate is. The climate norms are computed over 30 years. We use the same reference in the whole world.
Can you tell us about weather balloons? What are they used for?
These are valuable measurements because it's the only means that enables us to make a vertical profile of the atmosphere. We can measure temperature, pressure, wind, humidity up to 36 kilometers. And thanks to this, we can have complete profile of the different weather parameters in the atmosphere. This profile feeds our weather models. It enables the models to initialize properly with good data. And then it makes the weather forecast a little bit better.
What other cool tools do you use for measuring and forecasting the weather?
We have at Meteo Suisse a big network of ground-based stations that measure the basic weather parameters like temperature, pressure, wind, humidity, precipitation, with these ground-based stations, we have this balloon. We have radars that measure the precipitation. In addition, we have satellites, measurements from the planes, because the airline planes make measurements of temperature and wind. When we have all these informations gathered, we have what we call the initial state of the forecast. And then we use a model to propagate and compute the weather evolution up to 5 days ahead. And then the weather forecaster has the job to interpret the forecast, to extract the most important part, and to translate it into a language that is understandable for the general public.
What's an interesting math concept that you use in your job?
We do not directly use math when we are weather forecaster. We use the model's outputs, which stem from mathematics and algorithm. Maybe a concept that we could describe here is the chaos of the atmosphere that we can try to quantify to some equations. I think it's a really important topic right now because we have more powerful means of computation for the forecast, and we are able to quantify the uncertainty of our forecast.
How do you think AI is going to change your job?
AI may change our job in a very limited way at the moment because it supports automatization for different tasks and processes. AI supports our daily translations because at Meteo Suisse we need to translate the forecast into 3 languages. I think AI won't replace us very soon because we always need a physical weather prediction model based on physical equations describing the physical processes which take place in the atmosphere. And without this physical model, we cannot really produce forecasts that make sense. AI can help us improving the forecast, but it's a step afterwards.
This episode, we have a question that bridges the gap between weather and climate. Aude, would you set up our math question for us?
Sure. Let me first introduce the concept of climate normals. The World Meteorological Organization captures weather variables like temperature, precipitation, and humidity every day. Then they average all data over a 30-year period as it is considered as a representative period for the climate.
Why 30 years?
The weather is changing a lot from year to year. This is what we call in weather science interannual variability. So we need a period that is long enough to avoid such variability on the annual scale. And that's why we take the average over 30 years, because it smooths out the year-to-year variability and gives us a long-term pattern that we can use to talk about climate system.
All right, now listeners, grab your pen and paper. Here comes the math question.
Santiago is the capital of Chile. Based on the World Meteorological Organization's weather normals between 1961 and 1990, the coldest month was July, with an average temperature of 8.1 degrees Celsius, and the hottest month was January with an average temperature of 20.3 degrees Celsius. The next 30-year weather normal was 91 to 2020, where the July average temperature was 9.1 degrees Celsius. Compare the temperatures between these 2 periods.
Wow, that's a hard one, because we aren't asked for a numerical answer. I see a few things in the data. I wonder what patterns our audience sees.
Press pause if you want to analyze this yourself.
Okay, I put the data in a quick table. First, I noticed that January is the hottest month and July is the coldest. This is obviously because Santiago is in the southern hemisphere, where the seasons are mirrored to our seasons here in Geneva. Second, I see that both the cold and hot months are about 1 degree warmer in the second period, But let's run the numbers. Let's take the average of the hot and cold months within each period. For example, between 1961 and 1990, let's call that period 1, the average of 8.1 and 20.3 can be calculated by adding the two numbers together and dividing by 2. That gives us an average of the hottest and coldest months equal to 14.2 degrees. Doing the same for the 1991 to 2020, or period 2, 9.1 plus 21.1 divided by 2 equals 15.1 degrees Celsius. So my analysis would be that both July and January are getting warmer. By comparing the averages, I see that it was 0.9 degrees warmer in the most recent period. Does this hint at global warming?
You might be hitting on something, Jessica. Just a note to our listeners, our math question simplified the numbers a little. We only looked at the hottest and coldest months, and not the full year. According to the WHO data, the annual average for the year is actually 1 degree Celsius, but a 0.9 is pretty close. We would like to remind our listeners that they can access our data sets in our show notes.
Wait, did I hear that right? Just 1 degree different? Does that even matter?
I don't know. Let's ask Aude. Do the 1 degree change in the temperature normals really make that much of a difference?
Yes, even if it seems very small, 1 degree globally on the whole planet Earth is a lot. Means a lot of difference because it means that the general weather frame has evolved. 1 degrees average means sometimes 3 degrees more. In Switzerland, for instance, 1 more degree on the global scale means almost 3 degrees more in Switzerland compared to the pre-industrial period. And this additional 1 degree is determining for many extreme phenomena. It means that we have globally a warmer atmosphere. So warmer atmosphere can support more water vapor, can contain more water vapor. So it means it has a potential to develop more storms, stronger storms, and also heavier precipitation. So this 1 degree seems very small, but it makes the weather phenomenon quite changeable.
This has been a lot of fun and super interesting. We have to go back to school now. Thanks for hosting us here at Meteo Swiss.
You're welcome.